Uh, Hello, everyone. It's my great pleasure to be here. Thank you very much for inviting me. And today I'm going to talk about the research work that I've done during my PhD around location analytics. But before that, I'm going to give you a little bit of story of how did I get to that point. So my career, I started my career with actually entrepreneurship. So I was, there is a mistake there. It's from 2005 to 2010. I was heading a small software engineering firm in Ukraine, which I'm going to talk about. And then I did PhD in Italy in collaboration with University of Cambridge. Then I did a postdoc. And finally, today, I'm a data scientist at Skyscanner. So I don't recommend everyone to take the same course because it was quite unlinear, but here we are, right? So I started that my journey in 2005 when essentially that's me in 2005 with two of my co-founders. So we started a spin-off, university spin-off. We were three of us were lab assistants. And we were just starting our master's program in computer science. So because we were like lab assistants, we had free equipment, which were kind of unused in the free time. And we were also, every one of us wasn't really employed. So, the commitment was quite easy. No one had to quit the job because no one really had one. And then we didn't need any investment because we had our equipment from the university. The actual problem was, how do you start, selling your service if you don't have any previous history? So what we actually did back then is we used our courseworks from uni to show as our portfolio. So we nicely presented them. We made a little bit of design, and we said, here we are. We are doing custom software engineering. Here's our work. And all of the previous works were actually our university's courseworks. So that's how we started. And that was 2005 for I don't know how much of you remember that, but that was the time when the thing called Ajax just began. So previously, before that, the HTML pages in the browse, they were static. So any interaction with, with the browse required you to reload the page, from scratch. What Ajax allowed is to make this interaction more dynamic and easier. And that sprang quite a revolution in all online services. So that's how. So what we started doing is essentially, we can do Ajax, right? So over the course of maybe 1-2 years, we did all this nice Ajax website. So we worked for we had partners in Silicon Valley. The banks.com corporation, which kind of controlled a bunch of .com websites, which they got in aftermath of .com bubble. And we specialized. We specialized in Ajax software engineering, and we helped them create all of these websites. Then in 2007, another kind of epoch happened. So Ajax, overnight Ajax was not cool enough any longer because Apple released a new, device with a new groundbreaking kind of interface. And so, all the interests of, many customers shifted to this new toy. And what we had to do is essentially, follow the same trend and overnight re-specialize in iPhone development. And so we did. It was actually quite interesting times because it was a brand new technology. No one knew how to use it. No one knew how the actual design should look like. Whether you need to create a, a website, like an app for every single client, or you need to create platforms, or how different user interface things would work. So all of that was like a huge field of experiments. But what I started noticing later is essentially, well, I was young, I was 21 or something, but those, revolutions keep happening every single maybe year or every single 2 years, and you essentially every time had to catch up, right? So on my quite short memory, I witnessed, a bunch of those revolutions. So first, Ajax, then, social media. So in 2004, I think Facebook started, and then in 2006, Twitter started, and all of our customers suddenly wanted, to create a brand new social experience. And then later in 2007, iPhone released, and everyone suddenly wanted to build apps for this new platform. And now, if you project that further, then you see like 2000 something, big data. Later on, artificial intelligence. Now, deep learning or augmented reality. All of the things. So we figure out that essentially the strategy is that the strategy that we had to take was that you have to always requalify for this new changing environment. So you have to spot the technology as early as possible when there is suddenly overnight there is a lot of demand for that, but very little supply. You harness it as quickly as possible, such that you become a pioneer of that technology. As long as you are a pioneer, you get, it's a richer get richer strategy. So everyone who got it first got a lot of got more and more projects. We had to keep, the balance that we need to optimize the processes. And essentially, using constantly improving our internal processes such that to minimize the cost. We definitely needed, access to great talents for all this enterprise to work. But we also realized that we should be constantly, being ready to pivot every time, because every time the new technology is coming. Because that was the only way kind of to survive as long as you are doing this custom software engineering. But it worked quite fine, and we were making quite a lot of profit. We grew like to 20 developers, maybe, yeah. So it wasn't like a significantly big enterprise, but it was doing the job, and it was bringing in cash quite stably. Until the financial crisis started in the end of 2008, as far as I remember, but it touched us probably a year later, where suddenly we lost all of our overseas clients. We still managed to survive because we had clients from our local markets, from Ukraine. So I'm originally from Ukraine, and we had also customers, because the crisis kind of it was reaching, it was spreading across the planet quite gradually. So it hit severely US. We lost our US customers for a while, but by the time it came to Ukraine, it was already maybe 2010. So we were like in good shape working with our existing Ukrainian and Russian customers, and had time, for US market to kind of refresh. But we didn't fire anyone, so we really it was tight times, but we kind of survived it. But it made me thinking about a pivot, a possible pivot. And one of the possible ideas for a pivot, which we explored back then, was to refocus from custom software engineering, which was our premier business model, to essentially building a product. And we started working on this idea of which was called crazymenu.com, which was around search of restaurants. And we had quite a lot of ideas which were a little bit ahead of time, but they were quite unique and quite unique in the market. For instance, this was, once the iPhone 1 released, we immediately released this app, which was essentially the same functionality as you can get with Yelp, although it was still early days for Yelp, but you had all other, funky, interesting things, like this widget on the left. So it was making your recommendations of 10 different restaurants, but you don't, just see them right away. You had to scratch, the bar in order to get, a suggestion. And that was, just when iPhone 1 released, and no one actually knew what is touchscreen and things like that. So it was really, a very unique and popular idea back then. We also had, other things like menu recommendations, and you could see the menus. There was a separate app for restaurant owners to actually create these menus, but you had pretty much the same functionality as Deliveroo or all this Uber Eats or all these apps which are popular now, but that was back in 2008, right? So we had quite a lot of different things there. We had also integration with chatbots. So we had our chatbot, so you could write to Twitter, suggest me a restaurant. Like there was a Twitter bot, and you could write him, suggest me a restaurant around this street, and it would return you like a restaurant around your zip code. And that, again, was in 2008. So it has a lot of interesting functionality, but it didn't make it. For whatever reason, it didn't make it. My personal take why we didn't succeed with this one was we just putting too much functionality rather than focusing on the user and nailing it down for one specific feature rather than just creating all possible things. So back then, I had like Stanfy.com, which is customer software engineering company running, which was doing some good revenue for me, but the only way to scale that was to hire more engineers. And I had this crazymenu.com idea, which unfortunately we had to shut down. And I was thinking, well, it's good, but it's not enough. So I made a pivot, and I started a PhD. That was a very crazy idea, pretty much as described here. Like, I didn't know what I'm doing. No one knew what I'm doing. My parents didn't know what I'm doing. It was just crazy things to do back then. Later, I figured out that it actually has a lot of commonalities with being an entrepreneur, because you constantly search for funding. So you're constantly under pressure, and you need to essentially survive and be super competitive in order to get your PhD funding, to get your postdoc funding, to get your funding once you are tenure once you get tenure position, to get your funding for your postdoc and PhD students. You have a chance to do something great, which is, again, similar to entrepreneurship. You run it yourself, so essentially you build it, you run it, you invent it, you have to sell it, disseminate it, except that you never get rich after it. So that's probably the main discrepancies. So I still wonder if people doing that, but I did. And the topic of my research was around this idea of using sort of new types of data, which came from my background working on Crazy Menu, to do location analytics for restaurants. again, the idea that comes from my previous days at Crazy Menu. And the idea was as follows. Essentially, it's called optimal rotation location problem. So given the number of spaces, places in a city, can you figure out, and imagine you are a retail owner, so you are an owner of Starbucks, coffee shops, or some other chain, and you have to figure out where to place a shop. So how do you figure that out? It's not at all a new problem, because it's probably as old as trade is. So there was a lot of literature in this area, and I talked to some retail chains. The feedback that I got is the way they do it right now is by making surveys. So essentially hiring companies who would pay people to go on streets and collect data from surveying people on streets. There is another piece of research focusing on using some other data sources, which typically quite expensive. My approach was, okay, there is all this social media data. Can we try to use that? So I focused on this app, which is called Foursquare. I don't know how much of you have heard about Foursquare. All right, so it's an app where essentially what you can do is maybe there is a local version. I'm sure there is a local version. So what you do is you check in at places. So, well, I got here, right? So I open an app, and then I find the Myra Business School here, and I check in and make my friends know that I'm in this place. It was started, I think, in 2009 or 2010, and it immediately got popular. It had this idea of gamification. So whenever you check in at places, if you check in regularly, consistently, you get a mayorship, so you get a recognition, you compete with your friends. So they had this gamification thing that made it really popular. And it's actually popular in urban places around the world. So I don't know if you can, probably I'll skip that, but if you go to this URL, you can see some very cool visualization of how people check in at different places. So this is Istanbul, if I'm not mistaken. And then you can see, you can really see how this data maps the regular user patterns, because you can see, how people commute from some suburbs to the center of the city during the day, and the way they do the opposite movement and how they move within the city. So it kind of shows that this data makes a lot of sense and gives some signals to it. So unfortunately, Foursquare is a walled garden thing, so you cannot get the data straight from Foursquare, but you can get it from those Foursquare check-ins which people share on Twitter. So Twitter is a kind of all tweets are public domain by the terms of agreement, and so you can collect that data and use it for your purposes, right? Especially if you are especially if you do that through Twitter, then you can get this data, right? So we collected this data set from New York, where we got something like almost 1 million check-ins. That was the early figures. We then collected more data, but we compared the figures that we got from this data set with what Foursquare reported officially as their coverage user base, essentially. And we figured out that pretty much 25% of user base we were covering by making the scroll of Foursquare check-in on Twitter. So again, what people do on Foursquare check-ins, on Foursquare, they check in at places, and they check in at specific places. And what you can also see, this is a Foursquare page of a specific coffee shop in the city of New York. And you can see that, that's Foursquare reports how many check-ins has been seen in this specific area in New York, right? In this specific, coffee shop in New York. Now, if you look at, a different coffee shop in New York, but just, a few hundred meters away, you also get the stats of that. Now, notice that this figure is like 30,000 check-ins, where this one is 6,000 check-ins. So, in a sense, this place is twice more popular than this one, vice versa. Although these places are located like, just 2 blocks away from each other. This is curious. This was very curious. And so we started digging deeper, trying to figure out why this one is twice more popular. So what makes, this place much better for a Starbucks than this one? So we focused on, I'm sorry, it's going to be a little bit technical, but no worries, I'll explain this. So essentially, we collected, we tried to do this analysis on across all possible venues, like all possible coffee shops and restaurants and other points of interest in New York, and we couldn't see a pattern. And then we tried to, to limit our search within specific chains. So we looked at Starbucks, which had around 200 places, so shops in our data set. Dunkin' Donuts, it's a also fast food chain, popular, and McDonald's, right? And so what you can see here, so this plot shows how probable it is to find a shop with that number of check-ins in our data set. So the way you read it is say, how many shops have more than 1,000 check-ins? How many Starbucks shops, which is red, have more than 1,000 check-ins? Well, there's quite a lot, right? There is like, I don't know, like more than like 50% probably, right? How many McDonald's have shops with more than 1,000 chickens? Well, none of them, right? So it kind of shows you that you cannot compare, one retail chain to another one for some specific reason, hidden in the biases of this data set. It might be that that Starbucks chain they used to provide that was back in 2010 we collected this data set. They used to provide free internet, free Wi-Fi. So maybe it was a higher chance that someone who comes to Starbucks to check in just because they had Wi-Fi there, right? Maybe because people were of a different demographic was checking in Starbucks or something like that. But the truth was that it's difficult to make comparison against shop of different chains. But it seems quite reasonable to do comparisons within one chain. And that's the assumption that we used in this model. And then you can start figuring out what actually makes place one coffee shop of a specific chain more popular than the others. And notice in this example, so this is the example that we used in the one of the initial slides. So notice that it's located near to a big transportation hub. So maybe that's the reason why this coffee shop is quite popular. So we did some analysis. I won't go into details of it, but essentially what you can do is you can measure the probability that a certain shop will appear next to some business type, right? So one type of local business appearing next to the other one. And you can come out with these coefficients, right? So which says, how likely it is that Starbucks will be located to a train station. And you can see that it kind of confirms our expectation that Starbucks are located to train stations. McDonald's are located to, well, some of this is not really probably that reasonable, but like train station or Dunkin' Donuts next to hostel. So some of these ones might be actually not a causation, but a correlation. So let's say we observe that flower shops are situated very so McDonald's are likely to situate next to flower shops, but that might be not a causation. Not necessarily McDonald's, strategize to put their shops next to flower shops, but rather, they use similar strategies such that eventually, whenever you see a McDonald's, there is a high chance to see a flower shop next to it. So it's a causation, it's a correlation, not the causation. Next, you can do a similar analysis by looking also at user movements, right? So instead of just looking which places locate to each other, you can see how many of people who checked in at this train station afterward checked in in a Starbucks. And you can get, a sense of what is the movement patterns, what is the human mobility sort of patterns between different local businesses. So you can get, again, that, train station went slightly down here. Hostel emerged, like a much more probable companion for Starbucks. So it gives like a slightly different view than just, collocation patterns. It gives more a flavor of how people actually move. Right, so we got a lot of analysis like this. I don't want to go into much of details of that, but you start sensing of, what makes different businesses, what are the strategies behind their placement, right? And then you can come back and ask our original question, which is how, given a number of places in a city and using this piece of very fine-grained details about where places are located and how people move, can you actually solve the problem of retail placement? Which is, again, you need to choose between all of them. You need to choose one, or you need to rank them, right? So the way we solve that is essentially we defined so-called neighborhoods or areas. And we define them as a circle of a radius of a given radius. We use the radius of 400 meters. I'll explain why. And essentially, once you get this circle around a specific point, so let's say this is a potential place where we want to put a Starbucks coffee shop, right? You can get a sense of all other venues located within the area, but also outside, right? And then you can define different signals which explain, what's the popularity of this place? So how many check-ins you observe in that place, right? Or you can say, what is the competitiveness of places in this area? Which means for a coffee shop, if you want to place a coffee shop there, how many other coffee shops are already there? Or you can find, you can define things like what is the internal flow of people to this area? So how many people from outside, check in inside after checking in outside, or vice versa. But you can also define, using this coefficient of attractiveness, these coefficients, you can kind of take all of all these places and kind of see of what are different types of places allocated there and weight them by that coefficient, right? So you can say, okay, if there is a train station or there is a couple of train stations plus a hostel plus a, I don't know, a flower shop, then rate this place more likely for a Starbucks to open a shop there, right? So again, won't go into details, but you can figure out many of these characteristics, numeric characteristic of this place. And then you can, why you choose 400 meters for the radius? So there was this previous work which described, which essentially measured the distance between, which measured the street maps of street graphs of in specific in a number of cities, and they figure out that the optimal definition of neighborhood from different perspectives like walkability and the average distance that a human can walk is approximately 400 meters. So then you can, using all these factors, you can essentially train a machine learning model where you put everything together, like you put different factors in, and you train a model which gives you a prediction for how likely that, in this specific area, if you place a shop here, how likely based on all of these attributes that it will become popular. And the way you can do that is essentially a little bit technical, but essentially you do that as a standard machine learning exercise where you split your data into kind of training set and testing set, and you train your model based on the data points that you put in training set, and then you measure the accuracy of your prediction using your testing set. And there are a number of metrics that you can define on how well your algorithm performs. And specifically, we took the ones that were considered useful for ranking exercises, like this one, and kind of. So we measured how well we predict. We label the location as likely to open a specific shop there, and we measure, how the quality of that ranking. So some results essentially showing that we did a couple of exercises when we made these predictions based on individual features. So you take okay, how important is, let's say, popularity of an area to predict where a Starbucks shop will succeed using just popularity. And then we also use the model where we combine different factors in a machine learning model. And we got quite good results when we actually use some of the machine learning models. Yes? So the metrics that we use for popularity is number of check-ins in that place. Yeah. So we used Foursquare both to define how popular is the place, but also to measure different metrics. As a side note, we use the same approach to essentially for a different problem where we use the same features and we use the same data set to define features, but then what we were predicting were actually the house prices in London, right? So in this exercise with house prices, we were using Foursquare as our signals, as a kind of signals that describe location, but we used the labels which we were going predicting, the house prices taken from a different data set. And the results were as good, so they were quite accurate as well, right? So some other kind of works which can get you, which were inspired by similar approaches is this project called the Livelihood Project, where essentially they used the same data, very similar data set from Foursquare, and they tried to cluster places based on how users move, right? So they use similar features. So they defined, okay, what is the, what are the places that this specific users moves around? What's the composition of these places? So whether that's places of single type or is it different types of businesses? So they used different features which describe that specific place, and then they applied unsupervised machine learning models like clustering to figure out what sets of nearby located places makes more sense from perspective of these things. And what they found, what they came out with, is essentially a map where places are clusters based on these features using clustering algorithm, and you can find different kind of neighborhoods in the city based on kind of inspired by this data. From what I know, they ran some project with the second slide. Another work was with the title "Where is the Soho of Rome?" They actually tried to solve this problem, right? So Soho is essentially this neighborhood in New York, and also there is a Soho neighborhood in London, with a lot of kind of restaurants and a lot of attractions for tourists, but also like different food places. So what they try to figure out is whether we can, define what is Soho and then find similar neighborhoods in different places, in different cities. So essentially, you figure out what makes, from Foursquare check-ins again, you figure out what makes Soho, right? So what are types of places that make Soho? What are user, mobility patterns within Soho which makes it Soho? And then trying to find similar places in different other cities. Like where is the similar neighborhood in Rome or Barcelona or somewhere else? Very interesting work. Really encourage you to take a look. This was another interesting thing regarding to gentrification. So in this was actually not an academic paper. This was a blog. And what the guy done that is essentially they measured, they came from the observation that places which are considered posh, where the house prices are quite high, and luxury apartments and all of that, they typically are associated with the increasing amount of coffee shops, right? For some reason. Whereas the places which are deprived, bad neighborhoods, they typically have a higher sort of ratio of chicken shop inside them. So they come out with this coffee shop versus chicken shop index, assuming that that this threshold, this trade-off between these coffee shops and chicken shop can be a hint of gentrification of an area. And so this is, for instance, the share of like the areas with a high concentration of chicken shops. This is the area of high concentration of coffee shops. If you correlate these things with house prices, you'll see that there is a very high correlation when in places which are full of coffee shops but very little of chicken shops. And then you can come out with an algorithm which essentially rates places where this concentration is high enough already, but prices are still low, meaning that this place is already gentrifying, but prices are still low. So it's a very good place for investment, right? So you can buy an apartment there, right? Or you can invest in real estate. And this is a map of coming out from that analysis. So there's some areas, like I live in this area, by the way. So there is some areas where essentially it's becoming gentrifying, because you can see that from the data, but the prices are still quite low. So you invest in that area, right? Another work, this is from Computer Lab in Cambridge. So what they did there is essentially they also looked at the metrics of urban diversity. So they looked at graphs where, on one hand, you have a user friendship graph. So the graph on the top is based on user friendship links. So U1 are users, and then they are connected if they have a link on, if not mistaken, Twitter or Foursquare or both. And this is a graph of locations. And essentially, the graph are connected here if they share at least one users who come into both places. And then you can essentially look at kind of a graph, a sort of bipartite graph, which comes as a combination of these two graphs. And you can define different characteristics of a place. So for instance, you can say, what are kind of people who come into this area? So if the kind of people who come to this place are typically friends, it means that that's the place where people from the same community gather. Whereas in contrast, there might be some places where people meet which don't have any connection in social networks. So they called like brokerage places, right? And you can define different metrics of places by looking at this, relations of what kind of people are coming there. And so you can do next is you can define different metrics based on this graphic. So you can define brokerage, which is what I described. You can define entropy by just looking at the entropy, so the diversity of different users who come there. So the entropy is high if a lot of different people come to that place. Entropy is low if only very little set of people comes and quite regularly. You can define homogeneity and other different properties on this kind of location to social network relationship. And then you can correlate that with different demographic data that you get from public open data set. So for instance, there is a so-called index of deprivation, which is published by the UK government, which gives you for a given neighborhood different characteristic of unemployment, living environment, and different things. So you can make a correlation between the things that you define from social networks and all these government-based indexes. And what they found is there was very high correlation between some of these metrics, especially brokerage and some of the deprivation indexes, such as living environment, which suggests that you can use that data, which is much more fine-grained, because this one is only on a neighborhood basis, it's based on surveys, and it's being published only once in a while. Whereas you can use, Foursquare data, which is free to get, insights on this far ahead and essentially faster and cheaper. Another interesting research was around the street patterns. And so this work, they analyzed the patterns of street graphs. So essentially, you take all the streets and you see how they are connected to each other. And you can define, you can do that exercise across different cities. And then you can define two metrics, which says the efficiency of the street network and its cost. So the efficiency of the street network is defined as a kind of shortest path. So what's the average kind of path that I need to come from point A to point B in a city? So more efficient means that you have a lot of shortcuts to take to navigate fast across the city. And then the cost means how much coverage, like how much roads you need to, like the total sum of all road coverage, right? So, and then they compare different cities based on these two metrics. What they found was quite interesting. They found that two types of city structures get a very high efficiency. So one of those are medieval cities, like European or Arabic medieval cities, where they have a town hall in the center of the city and then circles around it, and they historically built like that, like circles. So those cases are very efficient, but they are also quite low cost because people were in a process of evolution, building it, to minimize essentially the cost. Whereas another example where where road coverage is efficient is grid sort of Manhattan type of coverage, where essentially Manhattan grid, right? So that kind is also efficient, but it's much more expensive. So in many cases, it's much more expensive, right? So you can kind of come out with how you essentially build, organize your urban structures using this data. There was some interesting research around also using the images. So this is the study where they took they actually crowdsourced a lot of urban images by essentially asking users online, showing two different street view photos and asking which of these photos you prefer, which one looks more beautiful, right? So this way they collected a data set which says, oh, okay, this street photo is more beautiful than that one. And as a result, they came out with this very nice algorithm which you can use as a navigation tool, and it shows you it shows you a path from A to B, but not only the shortest path, but the one that goes through different landmarks which people consider as beautiful or happy. So you can essentially build, your path to happiness. Right. So I'll probably finish. We still have 15 minutes, right? So I'll touch upon a different venture that I went through recently. So now I'm a data scientist. So what the hell is data scientist? Again, it's a very difficult thing to describe because in many companies it means different things. So I'll just describe my experience. So I compared my experience in data science from my experience to previous research in academia, and what I figure out is I get the access to resources. So when you do data science, you get access to resources which you don't have in academia. And more specifically, one resource that I was very much concerned about is the access to the users, right? Because Skyscanner has over 60 million users, so you can run experiments on, with real users and get your feedback really quickly from a massive amount of users. So the project that I'm working on now, I'll briefly describe what I'm trying to solve here. So essentially, this is what flight industry looked like before Skyscanner was there. So end users could get the price tickets for flights from, for their travels using different kind of distribution channels. So you can either go to travel agent, you can go to airline directly, you can go to kind of traditional airlines. Those three guys, they kind of historically happened that they outsourced their price computation power to companies called global distribution systems, and there are three big of them, one in Europe, one in States, and then they're low-cost airlines. So every prices that you get from these guys are most probably coming from few of these monopolies. Whereas low-cost airlines are creatures which use different business models, so they kind of calculate. They have their own pricing engines. So what Skyscanner did, in a kind of very briefly, is that we aim to create an interface to all of those guys, such that you only query Skyscanner and you get options from all of them. And we have a good coverage pretty much of all of these counterparts. Online agencies, many of them, as well as traditional airlines and low-cost airlines, right? Now, because we have access to all of these guys, what we can start doing is creating itineraries which previously were not available. So things, for instance, that you travel from point A to point B. So you travel, say, from Barcelona to San Francisco, and then you can make a stop, and you can fly with, let's say, Lufthansa. You can make a stop over in Heathrow, and you can travel then with Delta to San Francisco. So you could make that previously only if these airlines had an agreement between them, which is usually not the case, especially if one of these airlines is a budget airline. So another case is you travel with one airline one way, and then you return with a different airline. So essentially, all of these things were not really available on a high scale before to the users. But since we get all the data, we can essentially start doing those things, right? What we found is that by doing those things, we can beat the prices. So the itinerary that we construct from this exercise of combinations can beat prices in more than 50% of user searches. So it's quite powerful. And in many, like in 1% of cases, which is still significant, we create itineraries for the flights, for the routes where you previously wouldn't see any other alternatives. So say you are flying from Mysore doesn't have an airport, right? Bangalore to Auckland, right? Or maybe from Bangalore to Lviv, which is a place in Ukraine where, small airport. So most probably you won't find any results if you don't use us. So that's essentially why we are building this. But there is a problem connecting to this exercise. Is essentially whenever you need to make this search, you need to check all possible combinations, right? And since if you come back to this, to this slide before, so whenever we search these guys, whenever user searches us and we search these guys, someone has to pay for that search essentially. So making those searches is quite expensive. And since by constructing those things, you are making much more searches, essentially it becomes a combinatorial explosion of search space. So you cannot really, you cannot afford those number of searches. That's why we're using machine learning models, which in a nutshell, they optimize for two things. So they optimize for the number of searches that they do on one hand, but they also try to construct as many useful itineraries as possible. And useful we define if they make into top 10 of the prices. And essentially, the whole optimization exercise is to figure out how to construct which itineraries to construct with a very and construct only those ones in which you are very certain, such that you only explore a very small number of searches. So what we achieved so far is we can construct most of the useful by using these machine learning models. We construct most of the useful itineraries in top 10 with just less than 10% of searches. So results of that is very inspiring. We tested that 5% of all bookings are done through that thing in our experiments. So people are really using that. We cut the costs by a significant margin by just contracting much more cheaper itineraries for our users. And we also improved user retention. So now I have 5 minutes to finish. So I'll just summarize my experience from being a data scientist, which is still very fresh, into probably 3 main learnings, which I did after being in research and being an entrepreneur before. So 3 main lessons. Well, this one is specific to if you are dealing with online systems, but essentially try it fast, right? So try it fast and run it through online experimentation as soon as you can get your hands on it. Because different theories that you can come out in academia with, oh, these things will work, these things will work. Once you put it in real tests with real users, they crash, right? So that was a big revelation for me. You have to try things in real world. Otherwise, it's just an academic paper. In many cases. I'm not saying all of the cases, but in many cases. Another thing I found quite useful is that communication is really crucial, especially in companies, quite big companies. Well, Skyscanner is not that big. We are 1,000 people. Well, our parent company is much bigger. We are 1,000 people. But I managed to meet so many people from diverse background at Skyscanner, people from commercial background, people from business development background, people who who manage relationship with our partners, and it was really crucial for me to talk to them, because previously I was like in a bubble of academic researchers, and you get stuck in that bubble because you don't get that external perspective on things. So what I've do as an exercise is I try to talk to as many people in my company and outside as well, but even like in my company, to get as much more possible insight as I can. And there is a good book which I read a couple of years back on that topic. And the book was called Never Eat Alone. Essentially, the idea of that is you never eat, kind of have your lunch alone. You always go and grab it with someone, because that's a very cool, cool way to connect with people. So I really recommend this approach. Maybe there are many dozen other books on this topic, but I found this one quite useful. And there is also another insight which I found quite useful working in a company as well, is this approach called Lean Startup. It's Lean Startup without R. Essentially, the idea there is that you have to quickly iterate. You have to quickly access, you iterate quickly by coming out with concepts which are very simple, very easy to put into kind of real production and get the feedback from users. So for instance, if you design that approach for location prediction, don't go for sophisticated model. Come out with something simple as chicken shop versus kebab shop example. Go and test it on real users. Like, go and test it on real systems, whether it works. And once you get there, you measure and you kind of make your learnings, and you build it again. You iterate over and over again. So this is all from me. Thank you very much for your attention. I hope I gave you some insights in this interesting research area. And I also want to make use this occasion to say that we are hiring at Skyscanner. So if you want to become a software engineer or a data scientist or a commercial person, please contact me. We are hiring in Singapore. We are hiring in London, Edinburgh, Miami, and a few other offices around the world. Thank you very much.
Predict the Soho for Mysore, so we could put some money in there.
That's a very good question. I don't know. I would love to make that exercise. I guess as long as the data is there, you will probably find a place which, closely resembles Soho. Mysore. So it's basically, I guess we are referring to this paper here, right? So essentially, the way they did it is that they took all the types of places in a specific neighborhood, and then they measured different characteristics of that place. So chicken shop versus kebab shop might be one of them, but it's not necessarily. It might be also how heterogeneous are set of places. So if it's only, say, residential area, you would probably only see the residential buildings plus, some local businesses of a kind of limited variety. Whereas if it's, Soho is the place where you get, different restaurants clustered in a single place of different types, different, shops, retail shops, and things like that. I'm not that good in geography of Mysore to tell you right away, but I'm sure there is a place like that in Mysore.
Actually, the correlation between chicken shop and the even stronger in the US. It's been used there. They use one more measure, the availability of check cashing places.
Mm-hmm.
Places where they cash the check.
Right.
As compared to bank branches.
Right.
That has been used as another measure.
That's a very interesting idea, yes. I haven't heard about it.
That's used as a measure of non-gentrification.
Right.
I had a question now for the location of a store exercise you did.
Right. Mm-hmm.
You used data from Foursquare. Have you compared the results of that with the data from a traditional source?
So I didn't do that in this exercise because I didn't have that data. But one of my co-authors, he worked for retail. Well, he worked for a startup in Canada with a retail chain with real data, and he confirmed the results that you can use the same approach, where essentially you train like your labels, like you say, I want to predict, the the real popularity or revenue from a shop based on Foursquare data. Yeah. And the other exercise that we've done, and it was quite successful, is we used Foursquare check-ins as a data set for features, but we used the house prices from London as a kind of label that we were predicting. And it worked quite well. We had to adapt a little bit approaches. We couldn't do that on a per property because the data set it was given price per property, but it wasn't saying like whether this property is a first floor, or with a view or without the view, and what type of property. So what we have to do in that exercise is to aggregate and make predictions on a kind of small neighborhoods, but it worked.
Hello, sir. Sir, yeah. Along with check-ins, people sometimes do give feedbacks. So while determining the popularity, the feedbacks were considered.
Very good idea. We didn't consider, no. It was a little bit more difficult to get it, but that was one of the reasons. But that would be a really nice data source, because you can also get the the sentiment, not only popularity, but the sentiment. So there's some data set from Yelp. I think that they released as a kind of data challenge. So you can use that data, but I personally didn't try that.
Sir, but if the check-ins are increasing, it's obvious that the feedbacks are positive, isn't it? Because then only the check-ins will, what I believe.
Might be, but yeah, maybe it gives you a perspective of for what kind of, if you consider coffee shops, it's probably clear, but if you want to consider, different restaurants of different types, it can give you a perspective. This is a popular shop for vegans, or for people who prefer raw, food or stuff like that. So you can probably get, and the sentiment. I think that there is a potential in sentiment. So I would try the sentiment there as well. Yeah, that's a good point. Yeah, that's a very good point as well. With tweets, it's a little bit more difficult when it comes to Foursquare check-ins, because if you share your Foursquare locations, most of the users, they just click check-in, and the tweet is a kind of standard pattern, like, I checked in this place. There's no much information that you can get there. But there's another, tweets which are not connected to Foursquare, which are just geolocated tweets. So you can enable geolocation in Twitter, and then every of your tweets will be assigned a GPS coordinate, so you can use that. So in that case, you can do some interesting analysis. The one that I saw were mapping the languages in a study. They mapped the second language in different districts of London. So and created this map where essentially you can see in different neighborhoods, that will be neighborhood where most people would use Polish as a second language, and the other one would be, I don't know, Chinese or something else. So they use Twitter geolocated. Yes, and not the sentiment, just the language. Yeah, yeah, yeah. But that's everything connected with. I feel personally that everything that connected with natural language processing has a lot of potential to do with location. A lot of things can be done. Yes.
Like you said, you divide that check-in data into two parts, like testing and observe.
Yep.
So your algorithm have reached what level of accuracy rate?
So I think the accuracy. So accuracy is here, and essentially this is given all the places. What's the accuracy of targeting your best place in the percentage of this list? In the top 5% of that, the place that you predicted as the most popular will end up in top 5% of all places that you use, which is hundreds. This is the accuracy of that prediction. Yep.
So
Can you repeat that, please? I can hear.
Sir, how different is geo-spotting from geofencing?
So geospotting is essentially the term that we created. So there is like, it's not like a definition of a existing kind of term. It's something that we came out with. I'm not familiar with that one.
Which can be based on a mobile device that say I want to advertise people who just come into my zip code, for example.
Oh, I see. Right.
So that's geofencing. So geospotting will be a subset of geofencing. When you spot somebody and they are within your domain region, then you can identify them and target your ad more precisely.
That's very interesting, actually. It's probably, it's a different angle, but
two different concepts, but you can probably merge the two and leverage that.
Yeah.
In some case, it's a marketing concept, really. No, this geospotting, let's say, I have been identified as a potential customer of a restaurant. Geospotting says I am in Manas Gangotri. My restaurant is in Kalidasa Road. So it doesn't make sense to send a tweet to him or an SMS.
Oh, I see.
Yeah, geofencing services are there. Yeah.
Which one? The for. Yeah. Right. Yeah. You can probably. Yeah. Well, yeah, for sure. That's a limitation. But you can, for instance, like in this exercise, what you're doing is you're predicting what will be the location where a restaurant will be very popular, right? Or for a general, person. So maybe, you can target that for not for general person, but for person from specific demographic or from specific. So
this is an analytical tool, whereas geofencing is a live marketing tool.
Oh, I see. Right. Interesting.
About your McDonald's and flower shop.
Yeah.
I was thinking, is reverse possible? Maybe wherever McDonald's is there, somebody is keeping a flower shop. Is that possible that way?
So
the reverse way?
Might be, but it might be also like the explanation that we came out with is, look at this example. This is quite an anecdotal example, but essentially this Starbucks is popular because it's close to a train station, and the fact that flower shop is next to a Starbucks is probably because it's close to a train station, rather because because Starbucks and flower shop collocation somehow correlated between each other. So it's essentially a correlation. It's probably they apply like both flower shops and McDonald's. They might use some similar strategy to target, for instance, train station, and as a result of that, you observe flower shop next to a McDonald's. Although there is no direct, causation effect between them. At least that's what we came out with, some other kind of analysis. That's probably the reason. But thank you very much again for your attention.